Today I want to show you how to apply clean architecture to ASP.NET Core so that you can build applications that are easy to maintain and evolve over time. But before we jump into the code, there's one important rule to keep in mind since it's key to how clean architecture works. That rule is known as the dependency rule, and it states that source code dependencies can only point inwards, and nothing in an inner circle knows about anything in an outer circle. So following this idea, what that means is that whatever you have in the use cases circle over here can totally reference stuff in the entity circle over here, but it can never even know about stuff in the green circle over here. And same idea, you have everything in the green circle, it can only reference the use cases, but it can never know anything about stuff in this blue circle over there, right? And that's also the idea of these arrows that you can see here. So we're going to go over each of these circles in a second, but just keep this in mind because it is key to understand how the dependencies work in a practical implementation of clean architecture. So let's go into the first circle here, which are the entities. So what are these entities? These entities are the ones that define enterprise-wide business rules, right? So they're rules that apply to the entire organization, and these can be used potentially across multiple applications, and they are the least likely to change when something external changes, right? And here for a few examples of what could be entities, like user, game match, or org. Now let's jump into the code and see where these entities actually fit. So here we're back in Visual Studio Code, and the first thing that you're going to notice is that I don't actually have a project called entities or domain or anything like that, and that's because I decided to merge both entities and use cases circles in just one project that I'm calling core, and that's because I have not found really any practical need to keep different projects for those different situations, right? The theory says that you could have the same entities reused across multiple applications in your organization, but for practical terms, you will always define these entities for your specific application or microservice, right? And each microservice or application will define their own entities that pertain to their domain, right? It's very unusual that you will create a NuGet package to reuse these entities across the board. So that's why I found it much easier and practical to just merge entities and use cases and a few other things in just one project called core. Now, if you look at entities over here, due to the fact that we have this game match entity. So let's explore this entity very quickly. So here is a game match entity, and it's really a simple, very simple class that defines a constructor and a bunch of properties that refer to an actual game match, right? And there's also an enum down there. But the main thing about this entity is that it does have rules that are enforced right away, right? As you can see, to start with, you can only create the entity by using this constructor parameter, right? So you cannot just create a game match with no parameters and start setting values in there. Also because, as you can see, each of the properties are either getters or getters with private sets. So there's no way to set any of these properties without validations from the outside. So you have to go through to the gates that we have defined for those entities. So in this case, we have to make sure that the ID is not null or empty, and the same thing for the player one parameter over there. Only when we verify those, we are able to set the values and even initialize the correct state for the entity, right? So that's the first rule in this game match entity. And also, if we see here, if we want to set a player 2 for this game match, it has to go through this set player 2 method, which again, it is validating that the player 2 is not null or empty, and also, well, it says the player, and then it changes the state into the next logical step if everything else went properly, right? So the entity itself already has rules, right, which is key to the idea of having this rich domain that can be properly tested. And in fact, if we go back into the code over here, you're going to see that we already have some unit tests over here for entities, right here, game match tests. These are the tests that are specifically targeting that game match entity, right? You can see tests for the constructor over there. You can see tests for set player 2, right? So all of those rules are already being validated by these unit tests, even before we have any knowledge of any kind of infrastructure or UI or database or anything that is going to be used later on, because those are just details, right? As we say in clean architecture, those are not really meaningful at this point. But things get more interesting as we start bringing in the use cases. So if we go back over here and we switch over here, we have our use cases, which are the application specific business rules, right? The actual requirements, the scenarios that are related to a specific application. Now, these ones orchestrate the flow of data to and from the entities, and the changes in this layer won't affect the entities, and also external changes won't affect this layer, right? And so for a few examples of use cases, we can have stuff like, for instance, create a user, match players, or place an order, right? Typical examples of use cases. Now, going back into the code, you can see that we have this folder named use cases over here. And so the idea is to have one class over here per each of the use cases or requirements or scenarios in your application. And I chose to name them handlers, but you can choose to name them whatever you want. They could be named use cases, scenarios, requirement, whatever it is. But the idea is that, and let me open one of these, is that we have this one class that has just one method. If we go down here, in this case, handle async, which is the method in charge of satisfying or going over the use case by orchestrating the entities and using any other services that may be needed, right? So as you can see, and I'm not going to go across the entire use case here, but pretty much the idea of this scenario is that we have a match request for some player. And so we have to figure out if it's already in a match, or if there's a match that we can join him to, or if we need to create a brand new match, right? And for that, we're going to be collaborating with what we know as the repository and also a bus. Now, those dependencies, if we go all the way up here, you can see that we receive, by dependency injection, we receive an iGainMatch repository. So it's an interface for the repository, so it's an abstraction. We have an iBus, the interface that we're going to be using for publishing messages, and also an iLogger, which is interface or abstractions to be able to log messages, right? So it's all about abstractions. So nowhere in this class you're going to find any reference to any specific technology, right? Or either MongoDB or CosmosDB or SQL Server or RabbitMQ or Service Bus. None of that is going to happen over here because this is all about abstraction. This is all about satisfying the use case, right? Completing the requirement. Now, if you look at this interface, iGainMatch repository, where is that defined? That's actually defined in this repositories folder over here, iGainMatch repository, and all we have here, as expected, is just a few methods for creating a match, for finding a match for a specific player or a roving match or any of these things, right? But it's just interfaces. And just like we have this repositories folder here, you'd have another folder here named, for instance, services. You have other set of services that have to deal or help in some way any of your user scenarios, like an interface for sending an email, for instance, right? And the important thing is not to bring in infrastructure stuff. Now, going back into our handler over here, or use case, we also see that we have this iBus. This iBus actually comes from Mass Transit. It is a super handy library to abstract away the actual message broker that you're going to be using for your application. So if you see down here, that's what we use over here to publish a message. We don't know what actual broker we're using here. We don't care. That's a detail. All we need to know is that we use call publish with these messages over here, and it will be sent over so that other microservices or other applications can know about this event. Now, where are these messages and DTOs being defined, right? So because we can see that we have join match request over here, and we can have, as the input DTO, and as the output, we have gain match response. So where are those defined? Those are actually defined in another project called contracts over here. So I decided to put those DTOs in a separate project because those are going to likely be needed by other teams, right? In order to use my contracts. So for instance, we have the contracts here for requesting joining a game match, and also the contract for returning the response of a game match right there. Okay, but what we usually would do when we work with multiple teams is to put this or package this into NuGet package, right? And distribute this to the other teams that want to interface with those contracts or messages. If we put these contracts directly into the core, then we would have to, either package the entire core and share it with other teams, or we'd have to find another way to reuse those contracts, right? So because of that, I introduced this other dependency here, contracts. Is not mentioned in clean architecture, but I think it's a practical way to share this contract with other teams. Now, if you look at the dependencies of the matchmaker.core project, you're going to see that all it depends on is the contracts project that we just talked about, and then it's just a bunch of abstractions. The abstractions from Mass Transit to interface for message brokers, the abstractions for configuration to use the configuration system of ASP.NET Core, abstractions for dependency injection, and abstractions for logging. Right now, why do we need abstractions for dependency injection? Well, basically because if you see over here, we have this extensions class over here that defines just one method called addCore, and the purpose is that anybody that wants to make use of the types in core, all they have to do is just call addCore, and this is going to take care of registering all of the types defined over here. In this case are just the use cases or handlers for getting get match for player and for match player handler. Now, the cool thing about doing things this way is that since we have the use cases and the entities defined this way, and we don't have anything really about infrastructure defined over here, the cool thing is that you are kind of forced to find a way to test that all of this is actually going to work before even having a way to execute the system, right? Because normally you will go ahead and just run this and see if it works, but we don't have any infrastructure over here. We don't have any APIs, any actual thing that we can run and load and verify that it works. So because of that, what you have to do, you're forced to do is unit test, right? You have to unit test all of this. So if you go back and let me collapse this, you can see that we already have a test project over here. We have core, and then we have the test for, in this case, for the game match entity. And then we also have the use cases, right? So we have match player handle tests over here, which are a bunch of unit tests just to verify that one use case, which is the match player use case, right? We have 1, 2, and 3 unit tests. It's not extensive, but just to give an idea that we actually have a way to verify that the business rules of the application are working or not, even before introducing any details about the UI, database, or anything infrastructure over here. And since we have that, we can already go ahead and verify that everything works by just running all of our unit tests. So I'm going to go ahead and open my activity bar over here. I'm going to switch into my testing pane over here, and where I have my unit test, I'm going to click on this, and it's going to go ahead and start running all of my entity specific unit tests and also all the tests for the use cases. As you can see, everything passes. It was a super quick validation of all the business rules. We don't have to involve databases, we don't have to involve message brokers, anything that is actually going to slow down things that are actually very error prone, right, and flaky. In this case, we're just verifying the actual code of the use cases. There's nothing about infrastructure. So now we are confident that all the business rules have been tested. And we're pretty much ready to move on into adding a few details like the infrastructure details, right? So it is time to go back over here. And then we can move on into what we know as interface adapters. So these interface adapters are the ones that convert data from use case format into external format, right? And vice versa. And no code inward of these circles knows really anything about external circles. And so for examples of this, in terms of for instance, gateways, that would be our repositories, right? Classic repository pattern. And in terms of controllers and presenters, we can have the ASP.NET Core controllers, endpoints, background services. We also could have things like the mass transit consumers, right? So those are kind of the interface adapters, but let's see how that maps into an actual ASP.NET Core implementation. So let me go ahead and hide this activity bar for a moment again. And let me go ahead and switch into another branch, which is another branch where I have already prepared this additional layer, right? I'm going to click on restore here, I'm going to close this, and what we're going to see is that now we have this other project called infrastructure, right? Infrastructure. Now, this is the one where we actually define the concrete infrastructure pieces for our application. So for instance, the key case is going to be here, the repository. So remember that we didn't know about the repository before in the core, but in infrastructure, we now know that we are actually dealing with a Mongo game match repository. It's a repository implementation to interact with MongoDB. And so this will go ahead and implement the interface iGameMatch repository, which is an interface that, as you remember, if we look at core at one of our use cases over here, that is the interface that is being injected into our use case right here, iGameMatch repository. That is the interface, but the implementation is defined in infra over here, right? So here's the actual implementation. So here's where we know that we're actually using the iMongo database interface that comes from the MongoDB libraries, right? We build the DB collection and we do all the other things related to the specific MongoDB implementation, right? And of course, just like I did this, I could have done entity framework, a game match repository, right? That we could use to interact, for instance, with SQL Server or with PostgreSQL or any of those other things, right? But the important thing is that nothing in the core circle, right, or in the core project will know anything about this specific class over here. But then if the use case in the core layer doesn't really know about this concrete repository, how does it really know that it has to use it, right? So how does the magic happen? Well, the magic happens via dependency inversion, which is already set up in this extensions method over here, also in infrastructure, that follows the same idea with the add core method that we have in the core layer, but in this case is called add infrastructure. So add infrastructure is going to go ahead and use dependency injection to register all of the types for the specific interfaces. So in this case, it is creating a singleton for the iMongo database that is needed by the repository, and then it uses, as you can see right here, it is associating or registering the Mongo Game Match repository concrete implementation with the iGameMatch repository interface. And because of this one line here, whenever the use cases need that repository instance, they will get an actual concrete implementation of Mongo Game Match repository, even if the use case has no idea that such a class exists at all. right? So that's kind of the power of dependency inversion, and that's one of the key things that we want to exploit in clean architecture. We also have services for mass transit, and notice that it is right here that we actually define that we are going to be using RabbitMQ. We could be using Service Bus, we could be using Kafka, we could be using something else, but we define that here in the infrastructure project, nowhere else. All right. And if we see also the infrastructure project over here, we're going to see that here's where we actually get the dependency into MongoDB driver for MongoDB and into mass transit RabbitMQ to interface with RabbitMQ. Core project has nothing to do with that. We do get a dependency into core because that's a correct way to go, right? From the outside into the inside. That's correct. But core has no idea that infrastructure even exists, right? And then once again, we need to know, well, will this work at all or not, right? Because again, this is just a simple class library, right? It's just a standard class library. So once again, we can revert to unit test to verify that, this is the only way to verify that these are actually going to work at this layer, at this point. So now we have in test, we have this infrastructure folder over here with our repositories folder here, and also a unit test class for testing that repository. So as you can see, Mongo game match repository tests. This has a bunch of test cases specifically targeted to verify that the repository is working properly. It has nothing to do with the business rules, nothing to do with the game match entity or with any of the use cases. It's just to verify that the repository is working properly. So even if anything here is failing, it has nothing to do with the business rules that should be passing at this point because we verified that over there, right? And of course, once again, if we wanted to, we can go ahead and open up our activity bar. And if you go into our testing pane over here, and perhaps we need to refresh this to find our other test cases, we can now go ahead and run this, and now also our infrastructure test cases are going to run, and now we can get a clear idea that things are working or not, right? Now, once again, this goes very fast because we have not actually introduced any kind of actual infrastructure piece, an actual database or an actual message broker. We don't need those because of the repository abstraction. We can go ahead and verify that everything works properly before introducing any of those, right? So yeah, so that is the infrastructure project. So we are almost done with the circles here, but we still need one important thing, which is the next project, which is the one that's going to introduce the actual endpoints, right? And so that still doesn't move us away from this one circle. We are still in the green circle, but we need to introduce what is known here as controllers or presenters. So for that, we're going to go back into VS Code and we're going to switch. I'm going to my terminal. We're going to switch into the API branch that I have over here. And all we did here is to introduce, and I'm going to hide the activity bar, we have introduced this one brand new project called API. So this is the project where I like to put what is known in clean architecture as controller presenters. It's really just the endpoints, right? So if you see here, matchmaker endpoint, this is the one method that defines the endpoint for the application. In this case, we do have two endpoints. One that is used for posting, sending a post for joining a game match, and the other one for doing a get. So here you can see, where you can see that each of these endpoints are receiving both an input DTO, right? In this case, the join match request, and it's also receiving an instance of the match player handler, which is the one, as you remember, this is the one that handles the actual use case. So all that the endpoint is doing here is just receiving the DTO, receiving the instance of the handler, and then it just says handler.handle async. Right? In the same case for the other endpoint, the get endpoint, it receives in this case a player ID. There's no input DTO, it's just the player ID, and then it receives the proper handler for this use case, and then it just says, okay, go ahead and execute the use case. It delegates the use case, and then in this case, there will be one more line to decide if we want to return not found or we want to return okay with the match. Right? But the endpoint itself is pretty dumb, as you can see. There's nothing interesting really going on here, which is why I don't really feel like unit testing this code over here. I might as well just write some some integration tests for this, but not really that much unit tests. And of course, if you're using controllers, this is where you will introduce your actual MVC controllers if that works best for you. Now, if we go back into our project, we're going to see that we also, of course, have our program.cs. And this is what we know as the composition root, or is also known as the main component in terms of clean architecture. So this is where we wire up everything together. So this is where, as you can see in these lines over here, 7 and 8, is where we invoke first our add infrastructure method that we defined. If you see, if we keep track of the code, we go over there. This is defined in infrastructure, right? This is where we add all of the infrastructure types, right? And if you go back to program and then we go into add core, this is where we go and add all of the core types, right? So really the API project doesn't really know how to add infrastructure pieces or how to add the core pieces. It is completely delegated to those other methods, so things get super clean over here. And then of course we have this map get matchmaker endpoint, which is the class, the method that we just saw a second ago, right? So that's kind of the main component. And then if we look at Matchmaker API, the dependencies, we're going to see that all it has, I mean, it is kind of one of the dirtiest projects because it has dependencies all over the place, right? It has a dependency into infrastructure because it needs to add, to call that add infrastructure method. It has a dependency on contracts because each of the endpoints are going to need input or output DTOs. And it has a dependency on core because it needs to call the add core method also. And so at this point, we're pretty much ready to verify that the entire Clean Architecture application is working end-to-end. So for that, we're going to go through a debugging session. But before that, let's put a couple of breakpoints, perhaps over here in our match post method over there, and then in program CS, perhaps over here, where we register the dependencies. And then we're also going to open our matchmaker.http file to go ahead and start those requests. And now let's go ahead and hit F5 to start debugging. All right, and so the first thing that we see is that we are properly hitting our program.cs, so the composition root, right? So here's where we're going to go ahead, and if you jump into our infrastructure, we're going to go ahead and add our singletons over there for persistence and our singleton for mass transit, right? So we're going to go outside, and then we go into add core to also add the required dependencies for the use cases or the handlers, right? So with all that in place, the application will go ahead and start. So it's up and running now. And now we can go into Matchmaker HTTP here to go ahead and request that player one wants to join a match, right? So I'm going to click here on send request. So that's going to send a request into right here into map post. So we are starting, and let me actually show my Explorer over there so we can see where we are. So we are in the API project over here. So we have an instance of the request. We have an instance of the handler, the use case handler over there. So we're going to do F11. Okay, so we go ahead, we capture that player ID. We try to see if there's a match for this player one, and a match is null. There's no match for player one. Do we have an open match? And it is null, so it means that we don't have an open match for player one, so we can keep going ahead. We're going to go ahead and create a match, and now we're going to step into the repository, right? F11. Now we are in the infrastructure layer, right? In the create match repository method, and so we go ahead and we actually invoke the MongoDB library to insert this into the repository. And then we step out of that, and then we keep going on, just logging some messages, right? And then we go ahead into this method that transforms, right? It transforms the entity into an actual DTO, again, match response, which is what it's going to do right now. It transforms that, and then it heads back into our API project with everything done, and then well, we can just return. And as you can see on the right side, a bit hard to see, I guess, but as you can see there, we do have our brand new game match created. As we have player one, which is now waiting for an opponent, waiting for player two, right? And so yeah, that's Clean Architecture in action. And let me just stop this debugging session, and so I'll collapse all of this stuff over here. So that's how a Clean Architecture application can look like. But then of course we're still missing one more circle, right? If we go back into this, we do have one more circle, but there's no more code to add actually for this, because this is framework and drivers, right? So this is the place where external frameworks and tools live, and everything here is really just details that won't impact any inner circles. So in this case, we're really talking about the actual ASP.NET Core runtime, or the actual Angular or React runtimes, right? The actual applications that run Angular or React. And in terms of databases, we could be talking about the actual SQL Server implementation, or Oracle or Cosmos DB. And in terms of external interfaces, we could be talking about Stripe or Azure or AWS, right? So any of those are really completely external to the application. There's nothing really to code in there, but they remain completely in the outside, and the application itself is really unaware of those external details. Now, as a quick summary of what we did here, here's kind of a view of this practical implementation of Clean Architecture on ASP.NET Core. So at the core, we have, of course, all of our entities and the use cases, in this case as handlers, but we could also have a bunch of interfaces, like we saw the repository interfaces, but there could be many more services or interfaces that are needed by these use cases, but we keep only interfaces, only abstractions. And we could have also custom exceptions, we could have value objects, we could have a bunch of other things as long as they don't involve any specific piece of infrastructure, right? That's kind of the key. Then we also have our contracts project over there where we define the DTOs and the messages, and they're needed. I mean, core has to get a dependency in contracts because core is going to need DTOs as inputs and outputs for use cases, and also is going to need those messages in order to be able to consume them or to publish messages, right? And then we also have an infrastructure project here, which takes a dependency on core, and that brings in the actual concrete repository implementations or concrete other services that may be needed, concrete consumers if we're doing stuff like mass transit consumers, and then any other external service adapters that may be needed in terms of infrastructure, depending on what exactly you're interfacing with. For instance, if you're interfacing with a service to send emails, right, here's where you would interface at that specific interface, a concrete interface to send an email. And then we also have, of course, the API project, which is the one that gets a dependency on all of these guys here, and it's where we define the controllers, define the endpoints, and we also define the composition root, or the main component that is going to be the program, where everything is tied together so that the whole dependency inversion idea gets enabled, right, for the whole application, and everything works together. Finally, we also have our test cases, right? The unit tests. I mean, we just saw the unit tests and how you can enable those unit tests both for the entities, the use cases, and also for the repositories in the infrastructure side, right? So tests are going to get a dependency on core and infrastructure, and likely in that test project, you may also want to involve integration tests, or you may want to have another project for integration tests. But either way, this case project is going to get a dependency on those two ones over there. So there you go, a practical implementation of clean architecture for ASP.NET Core. And if you found this video useful, you will probably like this other video from my channel. Thanks for watching, and I'll see you in the next one.